A sequence of transformations, which is also known as a composition or composite transformations, is a combination of two or more transformations performed in the order that's listed, and each uses the results of the one prior. Meaning, for instance, if your pre-image, maybe you have triangle ABC, you would create your first image by some transformation. Maybe it's a translation, a rotation, or a reflection. And that first image, you would use your primes. So you would have A prime, B prime, and C prime, for instance, if you were working with that triangle. And then you would take that first image and you would apply that new transformation to it to get your second image. And the notation that you would use there is A double prime, B double prime, and C double prime. So this first example, we have the vertices of triangle ABC are listed here. I have them graphed here as well. It says graph the image of triangle ABC after the following sequence of transformations in the order they are listed and to label correctly. So our first transformation is a translation, and we can see that the vector here, it's our coordinate rule is x minus 2, which tells me that our points will move left 2 and y plus 5 means that they will move up 5. So each pre-image point, I'm going to move to the left 2 and up 1, 2, 3, 4, 5. And this is our first image, so we would label this A prime. So again, left 2 and up 1, 2, 3, 4, 5. So this is going to be B prime. And then C, we go 1, 2 to the left, 1, 2, 3, 4, 5 up. And you can see that I'm labeling them A prime, B prime, and C prime. And I can show that this is a triangle. Go ahead and close those shapes. And then we can write down our coordinates. So A prime is at negative 1, 4. B prime is at 2, 4. And then C prime we would have at 0, 7. So for the second transformation in our sequence, this is a reflection over the line y equals 4. And so we are going to take this new first image and reflect it. So you don't go back to the original pre-image. So the first thing I'm going to do is graph my line of reflection. Y equals 4, this is going to be a horizontal line where all of the coordinates on that line have a y coordinate, or all the points have a y coordinate of 4. So it's this horizontal line right here. So we want to reflect over that. Well, it just so happens that these 2 points are on the line of reflection. And so when we reflect over that line, they happen to stay on that line. So this point right here, which was A prime, is also the coordinates A double prime. B prime here, this is also B double prime. And then C prime is 1, 2, 3 units up above the line of reflection. So 1, 2, 3 units below would be where we have C double prime. And so we can connect this and you can see our shape. Again, we can write down those coordinates. So we kept negative 1, 4 and 2, 4 for A double prime and B double prime. And then C double prime is at 0, 1. And something that's important to notice is that a translation and a reflection, those were both rigid transformations. So it kept our triangles congruent. And so all three of them, they are all congruent to each other, right? That translation kept our pre-image and our first image congruent, and then a reflection kept our first image and our second image congruent. So what happens if you're given the picture? Can you describe that composition of transformations? So when you're looking at the picture, it's important to pay attention to what is the pre-image, what is the first image, and what is the second image. So I can see here that, let me trace it in red, this triangle that does not have any primes, it's triangle ABC, this is our pre-image. So the green triangle, I'm going to make it green right now. This has a single prime, A prime, B prime, C prime. So I know that this is the first image. So you could use patty paper, but you would be able to tell that this has turned. And we can see that it's turned in a clockwise, whoops, let me use my pen, a clockwise direction, which means we're going to have a negative angle measurement. And you can see that, for instance, this side and this side, that's an angle of 90 degrees. So it's going to be a negative 90-degree rotation. And our center of rotation is right here where both A and A prime are. So we would write this, we would say a negative 90-degree rotation about the point, and we would give its coordinates, -2, -1. So then we want to know, how do I get from the green triangle to this triangle with all the double primes? So I'm going to make this one blue. So here we can see that this is a slide. And so I need to determine, how do I get from A prime to A double prime, or from B prime to B double prime? So we can see that we're moving 1, 2, 3, 4, 5 units right and 1, 2 units down. So a slide is a translation. And we can give this as a coordinate rule or in component form. So we could say that this was x plus, I believe we said, what, 5 units? And it goes down 2, so that would be y minus 2. You could also write that in component form, 5, -2. Okay, letter B over here. Here we have A, B, C, D. So this is our pre-image. A prime, B prime, C prime, D prime is this image here. We can see that this is going to be a flip, so we have a reflection. So it's our job to figure out where exactly is that line of reflection. So if I draw in, let's see, there are 3 units between D and D prime. So our line of reflection has to be exactly halfway. So I know it seems kind of weird, but it looks like our line of reflection actually isn't on one of the lines drawn in there. It's at 1/2. So our first transformation is reflect over, and this is a horizontal, so it's going to be y equals 1/2 or 0.5. So now we have this image, and we can see that this is going to be a turn. So our second one is going to be a rotation. And I can see that this is going to be my center. You can always use patty paper to figure this out, but I'm going from here to here. So this is a 90-degree. And since it's going to be going this direction, it's going clockwise. So this is going to be another negative 90-degree rotation about that center point that we said right here was 1, -1, 2, 3. So 1, -3. Now a negative 90-degree rotation is the same thing as a positive 270-degree rotation. So if we wanted to, we could have also said that going this direction, this would be a positive 270 degrees as well. So anytime you're working with rotations, you actually have multiple ways that you can write those angles. All right, so the last thing that we're going to go through together is this set of problems where we have this segment FG. F is located at 1, -2, and G is at -2, 3. So I've plotted that in both of these. And what we're going to focus on here is, does the order of those transformations matter? Because here I'm reflecting over the line x equals 1 and then performing the translation with the coordinate rule x plus 2, y plus 5. Over here, I have them flipped. So we just want to determine if that matters that we flipped them. So over here, let's first reflect over the line x equals 1. This is a vertical line, which is right here. So if we reflect over that line, f prime is actually on that line still. So f prime still has the coordinates 1, -2. G, if I reflect that, that's currently 3 units to the left, so 3 units to the right is going to be over here at 1, 2, 3, 4, 1, 2, 3. So 4, 3 is G prime. So we can see our segment right here. Now we want to reflect this segment, or I'm sorry, translate this segment, and this is going to be right 2 and up 5. So if we reflect, or I keep saying reflect, if we translate that, right 2, so this F prime goes right 2, so here's F double prime, and G prime goes, whoops, I didn't do the up 5, so let me fix that. Getting a little ahead of myself. So we go right 2 and then up 1, 2, 3, 4, 5. There we have F double prime. And then same thing with G, right 2, or I'm sorry, G prime. And then up 1, 2, 3, 4, 5. So G double prime is up here. So we can see where that segment is. And F double prime is at 1, 2, 3, 1, 2, 3. So 3, 3. And G 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So G double prime is at 6, 8. So we can see what happened when we went about it this way. Now let's look at it if we do the translation first. So if I translate 1, 2 to the right, 1, 2, 3, 4, 5. So here's G prime. Again, 2 to the right, up 1, 2, 3, 4, 5. Here's F prime. So here's our first image. And again, we can write those points. So 1, 2, 3, 3 is F prime. G prime is at 0, 1, 2, 3, 4, 5, 6, 7, 8. So now we want to reflect that over x equals 1. So let me change my color. And again, I'm going to show you that line of reflection is right here. So if we reflect over that, that means G double prime is now going to be 1 unit to the right. F prime was 2 units to the right, so 2 units to the left. Here's F double prime. So we can see here is our final answer, where F double prime is located at negative 2, 3. And G double prime is located at, let's see, oops, I don't have that at negative 2, 3. That should be negative 1, 3, right? Because here's my y-axis, so negative 1, 3. And G double prime is over here at, this is 1, 2, 3, oops, just 2, 8. There we go. Sorry about that. So ultimately, we did not end up in the same spot, right? If we went through and we highlighted where our final one is, let me make this a little bit smaller. Our F double prime, G double prime here is this line segment, and over here, it's this line segment. So they do not end up in the same spot. So does the order of the transformations affect the location of the final image of that segment? The answer is yes, order matters. Okay, so I'm going to click through these final answers. You are welcome to pause the video and walk through these a little bit, but I know the video is getting pretty lengthy. Sometimes there's going to be differences in your answers, especially with rotations. Like I said, this is 90 degrees, or you could say it's negative 270 degrees, things like that.